Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket on smartphone battery life. And we are going to do a confidence interval, and it says calculate a 90% confidence interval for the smartphone battery life. So calculate a 90%, excuse me, so 0.90 or 90 divided by 100. And we already dealt with this scenario before. It says a company that manufactures smartphones developed a new battery that has a longer lifespan than that of the traditional battery. From the date of purchase of smartphone, the distribution of the lifespan of the new battery is skewed with a mean of 30 months. So this is the population mean and a standard deviation of 8 months. All right, so we have our population standard deviation. We know it's 8 months. A consumer group tested a random sample of 60 of these batteries from a batch of 1,000 and obtained an average battery life of 28. So this is my X bar. All right. And now we're just going to calculate that 90% confidence interval. So I need that formula. Formula for a confidence interval is X bar plus or minus Z star, standard deviation of the population, divided by the square root of n. Well, to get Z star, anytime we're looking for a Z star and we have a percentage, it's going to be inverse norm 0.90, and all z-scores have a mean of 0 and a standard deviation of 1. So here's my probability, my mean, my standard deviation, and we want the center. And when I go ahead and run this, I'm going to go second vars, second vars, inverse norm, area is 0.90, mean of 0, standard deviation of 1. It's already selected center. And we only take the positive value. So z equals 1.6448. Oops, I wrote that on the wrong line. So Z star equals 1.6448. All right. And then we're going to plug in. All right. So I need to plug in it asks for my sample mean. Well, sample mean is 28. 28 plus or minus Z star 1.6448. Standard deviation of the population is 8 divided by standard deviation of the sample. I mean, standard deviation of the sample size, the square root of the sample size. And our sample size in this case was 60. So standard deviation of the population, sample size right here. And now we're going to go ahead and run this thing. So we're going to go stat test, drop down to number 7, which is Z interval. And we have our standard deviation of 8. We have our sample mean of 28. We have our sample size of 60, and I need to change that confidence level to 90% because they told us they wanted a 90%. And there's my interval, 26.301 to 29.699. So interval, oops, I want it in red so that it'll show differently since I messed up a moment ago. 26.301, that's my lower, and my upper is 29.699. So there's my lower, there's my upper, and I'm gonna go ahead and label that. So we expect it to be at least 26.3 months and as high as 29 point, almost 7. But notice that's not the full 30 months. It doesn't quite get to 30 months. So that's interesting. So we can't say 30 months is plausible. It looks like it's less than 30 months. So what are we? Well, we are 90% confident that, and when we did the hypothesis test earlier, we defined the parameter, the true population mean battery life, that the true population mean battery life lies within the interval 26.301 to 29.699. All right. And if you're wondering where I defined that parameter before, that happened that we did an assignment video on this. And so just look for that assignment video where it says the true population mean battery life was defined as the parameter. All right. Sure hope that helped. Look forward to seeing you on the next one. Thank you.